This is to one and all. Myself, S. Bharati, Department of Mathematics, subject transform techniques. Topic is Laplace transform. We will discuss about only in PPT by basic concepts of Laplace transforms. Definition: Laplace transform of f of t. Laplace transform of f of t is denoted by L of f of t and is defined as that the integral limit is 0 to infinity e power minus st f of t dt if it exists. That means if it exists means the integral value will be exists. That only the Laplace transform value will be accepted. So now we discuss about the question. Prove that Laplace transform is a linear operator. So this is the transformation. So operator is a linear operator. In other way we can say that Laplace transform of a f of t plus b g of t equal to a l of f of t plus b l of g of t. Here a and b are constants. So proof: L of a f of t plus b g of t equal to, so this is the formula, integral 0 to infinity e power minus st, f of t is here a f of t plus b g of t dt. So we can integral values, we can separate a f of t e power minus st, b g of t e power minus st. So we can separate as two integrals, that is equal to constant is outside a integral 0 to infinity e power minus st f of t dt plus b integral 0 to infinity e power minus st g of t dt. This is the nothing but Laplace value formula. So L of f of t, this is L of g of t. Hence L of a f of t plus b g of t equal to a L of f of t plus b L of g of t. So simply it is a linear operator. This can be rewritten as, this is two types. One is L of f of t plus g of t. There is no constant here. So we can separate in linear operator concept L of f of t plus L of g of t. It is a constant k. L of k f of t equal to k into L of f of t, where k is a constant. So basic results in Laplace transform. The first result we will now discuss about Laplace transform of 1. 1 is not a function, that is a constant. So I will take as a constant what is the Laplace transform. So L of 1 equal to, the formula we can use in f of t is here f of t. 1 is here, so we can use in here 1. Integral 0 to infinity 1 into e power minus st dt. We can integrate e power minus st. This function is t. So there is a variable t. So e power minus st variable t. So e power minus st by minus s after integration. Limit value will be 0 to infinity. We can apply the upper limit e power minus infinity by minus s. E power 0 by minus s. This is upper limit. This is lower limit. If s is always positive, e power minus infinity, the value will be known 0. E power 0 will be 1. So we can using this. So 0 minus 1 by minus s. So after simplification we get 1 by s. Therefore L of 1 equal to 1 by s if s is positive. That is the constant value will be 1. General concept. So constant, general constant L of k equal to, simply we can say about k by s. This is the transformation if s is positive. Second proof, L of e power at. So L of e power at, you can use the f of t is here f of t. So e power at, you can use e power at. So e power taken common as t minus, because of the formula of procedure. So e power minus s minus at dt. So you can integrate e power minus of s minus at by s minus of s minus a. We can using the limit 0 comma infinity. Upper limit variable t instead infinity 0 e power 0. E power minus infinity is 0, therefore 0. E power 0 is 1 by minus s minus a. After simplification 1 by s minus a. This value will be always positive, that is s is greater than a. Therefore L of e power at equal to 1 by s minus a if s is greater than a. This similarly, this is a is a positive. Suppose it can be negative e power minus at, we can change only minus a is plus a. That is, you can change plus a to minus a. Plus a to minus a here. Suppose you can change a to minus a. This is minus a after minus plus a. So note L of e power minus at equal to 1 by s plus a. S is greater than minus a. So L of cos at. So we already know that L of e power at and L of e power minus at. We can using this cos 80. What is the cos 80 formula? So real part of e power iat. So e power iat means cos 80 plus I sin 80. So cos 80 plus I sin 80. What is the real part? Cos 80. So I will take it as cos 80 is nothing but real part of e power iat. Because t is the variable, so Laplace inside the variable t. So here is a constant, t is constant, coefficient of t is my ia. So what is the already result? One real part of 1 by s minus ia. Real part means the conjugate we can change in the by this way. S minus ia means s plus ia, s plus ia. So 1 into s plus ia, s plus ia, s minus ia into s plus ia. That is with a plus ib into a minus ib means a square plus b square. Simply s minus ia into s plus ia, s square plus a square. Therefore, what is the real part is s by s square plus a square. Suppose asking the imaginary part a by s square plus a square. So we can only real part. So we will take only s by s square plus a square. Therefore, L of cos 80 is s by s square plus a square. Therefore, cos 80 is the real part of e power iat. Suppose asking sin 80, imaginary part of e power iat. That is simply after this simplification this way, we get a by s square plus a square because imaginary part. What is the imaginary part is here? A by s square plus a square. L of cos hyperbolic 80. Cos 80 means real part of e power iat, but cos hyperbolic 80 is the formula is e power 80 plus e power minus 80 by 2. We can using the linear operator method. So 1 by 2 is constant is taken outside and the function we can separate it by the linear because Laplace transform is linear. So L of e power 80 plus L of e power minus 80. So L of e power 80 is 1 by s minus a plus L of e power minus 80 is 1 by s plus a. After simplification, we get the value is 2s by s square minus a square. The common will be 2 be cancelled. Then finally s by s square minus a square. So L of cos hyperbolic 80 is s by s square minus a square. Here s is greater than modulus of a because a square is here. So I will take as s is greater than modulus of a. Similarly, L of sin hyperbolic 80. This procedure we can using this. Cos hyperbolic 80 is plus, sin hyperbolic 80 is minus. In finally we get a by s square minus a square. This procedure of the proof is similar to like this, but here formula is cos hyperbolic 80 means e power 80 plus e power minus 80 by 2. Sin hyperbolic 80 means it's only minus will change e power 80 minus e power minus 80 by 2. So L of t power n. So t power n we can using this. We can using this is the integration by parts formula. So integration by parts we can separating u dv method. I will take as integral of u dv. So integral 0 to infinity t power n d of uv is e power minus s t by minus s. Suppose we can differentiate e power minus s t by minus s, we get e power minus s t dt. So integral of u dv. So integration by parts. So integral of u dv equal to uv minus integral v du. Therefore, uv minus integral v du. We can use it. So 0 to infinity. Du means t power n differentiation. N t power n minus 1 dt. So we can using the upper limit infinity e power minus infinity 0. We can using 0 lower limit 0 is again 0. Therefore, the total value will be 0. In minus of minus plus, the constant will be n s. So I will take an outside n by s. Variable is t. Therefore, e power minus is t. T power n minus 1 dt if s is positive. So we can this is value 0 n by n. This is the formula from Laplace transform. We get L of t power n minus 1. Therefore, L of t power n is n by s factorial L of t power n minus 1. We can simplify this simply in this way. So finally, L of t power n equal to n factorial by s power n plus 1. So for L of t power n we get this. This is n minus 1. So L of t power n equal to n by s power 1, L of t power n minus 1. Here is n. So here n minus 1. Suppose we can using this L of t power n minus 1, n minus 1, n minus 1, again 1 base. Simply going to similarly in manner. And finally we get this, that is simply n factorial by s power n plus 1. So friends, L of t power n equal to n factorial by s power n plus 1. Here s is always positive. Note the results in Laplace transform I have written below. We can found out before. So what is the function 1? Laplace transform is 1 by s, but the condition is s is positive. The function is k. Laplace transform value is k by s. Here condition is s is positive. E power at is the function. What is the Laplace transform? 1 by s minus a. The condition is s is greater than a. Now the function is e power minus at. Laplace transform value is 1 by s plus a. That is s greater than minus a. Cos at function. Therefore L of Laplace transform of cos at s by s square plus a square. S is positive. Function is sin at. Laplace transform value is a by s square plus a square. S is positive is the condition. The cos hyperbolic at value is s by s square minus a square. The condition is s is greater than modulus a. Sin hyperbolic at is the function. Laplace transform of this function is a by s square minus a square. The condition is s is greater than modulus a. Since e power n is the function, what is the Laplace transform? N factorial by s power n plus 1. The condition is s is positive. Thank you.